Welcome back. Let's talk a little bit about taking measurements and this idea of significant figures or significant digits. So the first thing we want to talk about is that all measurements, all numbers, are either a measurement or an exact number. So an exact number is something you can count. So the number of people in class would be an exact number. The number of buckets would be an exact number. There's no uncertainty. There's not like maybe 10, maybe 11 students in class. There's exactly 10 or exactly 11. A measurement, however, has some uncertainty. What do I mean by that? Well, imagine this graduated cylinder, okay? And in this graduated cylinder, right, I can tell pretty quickly that there's between 60 and 70 milliliters of water. However, is there 65 milliliters of water? Is there 64? That last digit is a little bit uncertain, okay? So I call that last digit here an estimate. And the way I'm going to estimate is I'm going to imagine between 60 and 70 that if I were to zoom in, there would be 9 markings between that, or 10 divisions between 60 and 70. Right, so if I zoomed in here, right, this is 60, and there's 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. And what I want to do is I want to imagine where that water would be. And if I think it's at, here, what happened there? If I think it's there, still having trouble with that pen. If I think that it's, not quite in the middle, I was at the 64 mark there, I would call that then 64 milliliters. So I would say, okay, this I would call 64 milliliters, and I say that last number is an estimate. Or in other words, I measure to 1 digit beyond the marking. This is marked every 10 milliliters. So when I record my measurement, I go to the ones place. Similarly, right, here's a 10 mil graduate, and it's marked every 0.1 milliliters, right? So this one's going to be a little bit harder to see, okay? If I zoom in, I'm not able to really zoom in, but imagine I could zoom in here, right? I'm going to say, okay, this is 5.1, 5.2, 5.3, 5.4, 5.5. I measure right to the bottom of that meniscus. Right? So I'm going to say that's 5.5 milliliters. Okay. However, I still need to go 1 digit beyond that. Right? Because I go 1 digit beyond the smallest marking. Now this is hard because it's very small marking, but we still want to record 1 digit beyond the smallest marking. Now, if I think it's right on 5.5, I would call this 5.50 mils. If I think it's just a tiny bit above, I could say 5.51. Tiny bit below, 5.49, and so on and so forth. So what I want you to take away here, no matter what equipment we use, and we're going to use a graduate and a balance in our first lab, you measure to 1 digit beyond the smallest marking on the equipment. Not the smallest label, the smallest marking. This one is marked every 10th, so I'm going to report that to the 100th. And we'll see this throughout the lab. And this is this idea. Now, why are we doing this? Well, the reason we're doing this is a little complex, but we're doing this because we want our recorded measurement that we're reporting to our reader, 64 milliliters or 5.50 milliliters, to give us some information about how precise the instrument was, right? When I see 64 milliliters, I know that was measured using a graduate that was marked every 10 milliliters. When I say 5.50 milliliters, I know that that was measured using a graduate that was marked every 10th of a milliliter. And that's the idea. And these numbers then become our number of significant digits or significant figures, which we're going to talk about next. So that's how you take a measurement. Here's what these significant figures mean. So significant figures give us information about the precision or the number of markings on an instrument. Now, how do we determine significant figures? Because it's not always exact the number of digits. It depends if the decimal point is present or if the decimal point is absent. And we have some rules for counting these significant figures to kind of help us. And these make the most sense with an example. So let's take a look at an example. So here's 4 examples, right? The first thing we have to decide is the decimal point present or absent? So for this one, it's present. In other words, it's typed in. So when it's present, to count the number of significant figures in the measurement, I start counting on the left with the first non-zero, okay? So in other words, this has 1, 2, 3, counting like that, sig figs, okay? So if I ask you to tell me the number of significant figures in a measurement, that's how you would count them for 2.12 liters. And we would call this 3 sig figs. 142 grams. This time, the decimal point is absent. We start counting on the right, okay? And you're going to say, well, Mr. Muggleberg, even if you start counting on the left here, you would still get 3 sig figs. Yes, I would, okay? Remember, these rules are helping us. All of this, why even count sig figs? We're counting sig figs so that we can work with them in the lab. So we're all kind of like we're in a getting ready phase here, okay? How about this one, 10, 20 kilograms? Well, this time, decimal point absent. Start counting on the right. But remember, you start counting with the first non-zero, okay? So the first digit I'm going to count is this 2, okay? But then once I start counting, I go all the way to the end. So these middle zeros do count. It's only leading zeros, zeros before I start counting digits that don't count. So this has 3 sig figs. How about this one? A lot of zeros in there, but remember, decimal point present, I start on the left with the first non-zero. 1, 2, 3, 4. This is 4 sig figs. Why do those zeros count? Those zeros count because they're not leading zeros. They're not a zero. If I had a 0 here, that 0 would not count. If I had a 0 after here, right where this marker is here, it would count. Last one here, decimal point present. Start on the left with the first non-zero. 1. And I'm gonna count on top here. 1, 2, 3. Okay, and that's 3 sig figs. Again, that ending 0 does count because once I start counting digits, I don't stop. And we'll talk about rounding a little bit in the next video.